A fundamental limit hides within the cosmos, a permanent blind spot known as the cosmic shadow. This is not a darkness you can see, but a boundary woven into the fabric of spacetime itself, a horizon beyond which knowledge is forever lost. We will explore a radical idea that shatters our understanding of time, the possibility that our universe's past is not fixed, but is actively being written by its future. This journey will fundamentally alter your perception of reality, revealing how the future could code the past. We will investigate how this explains why the Big Bang was so perfectly ordered and what really happens to information inside a black hole. What if everything you think you know about cause and effect is an illusion? This cosmic shadow is the universe's final curtain, a veil that no telescope will ever pierce. It is a horizon, but not one made of land and sky. It is a boundary in the very structure of spacetime, a point of no return for information itself. We are accustomed to the idea that we cannot see the edge of the observable universe because light from those distant regions has not had time to reach us. Yet that is a temporary limit, a frontier that slowly recedes as more light arrives. The cosmic shadow is something far more permanent and profound. It is a wall that grows taller with time, not a line we are moving toward. This ultimate boundary is intimately tied to the accelerated expansion of our cosmos. As distant galaxies rush away from us faster and faster, they will one day cross a threshold called the de Sitter horizon. Once a galaxy passes this point, every photon of light, every ripple of gravity, every last bit of data it emits will be stretched and redshifted into oblivion before it can ever reach us. It will vanish from our future sky, not just because it is far away, but because the space between us is being created so rapidly that information cannot traverse it. This creates a fundamental limit to what we can ever know, a permanent blind spot etched into the cosmos. It is the universe's own firewall, a one-way valve that ensures some truths remain forever hidden. This shadow defines the ultimate stage upon which our reality plays out, a stage with a fixed number of pixels, a finite amount of information, and that startling finitude is the key that unlocks a deeper mystery. If there is only so much information that can ever fit within our cosmic horizon, then perhaps our universe is not a vast, volumetric container, but a projection, a hologram. The three-dimensional reality we experience could be encoded on the two-dimensional surface of this ultimate shadow. The events unfolding around us, from the birth of a star to the firing of a neuron, might be the decoded output of information written on this distant boundary. But who or what is doing the writing? The answer may lie in the most dramatic event horizons we know, the black holes that pockmark our galaxy. These horizons are not solid walls you could touch. They are one-way membranes in the fabric of reality itself. Once anything crosses that threshold, it can never send a signal back. The most famous example is the event horizon of a black hole, a point of no return from which not even light can escape. But there is another, far grander horizon that surrounds us all, the cosmic event horizon created by the universe's accelerating expansion. Think of standing on a beach, watching a ship sail toward the open ocean. It grows smaller and smaller until it finally dips below the curve of the Earth, vanishing from your sight forever. You know the ship still exists, but you can no longer receive any information from it. No light, no sound, no message in a bottle. In our expanding cosmos, distant galaxies are like that ship. They are crossing our cosmic horizon, and the light they emit today will forever stretch into undetectable nothingness before it can reach us. They are fading from our future, not because they are moving away, but because the space between us is swelling so fast that their signals are lost in the tide. These horizons are far from passive boundaries. They are dynamic surfaces deeply connected to the universe's entropy, a measure of its disorder and information content. The physics governing these boundaries suggests something astonishing, that a complete description of our entire three-dimensional universe might be encoded on its two-dimensional surface, like a cosmic DVD. This is the heart of the holographic principle, yet a profound puzzle remains. When a book falls into a black hole or a galaxy vanishes beyond the cosmic horizon, what happens to the information they contain? It seems to be irrevocably lost, erased from our reality. This apparent destruction of information creates a fundamental conflict, a direct clash between our two most successful theories of physics. On one side, Einstein's general relativity, which beautifully describes gravity and the warping of spacetime. On the other, quantum mechanics, the rulebook for the subatomic world. And these two pillars of modern physics are at war over this very question. This conflict between our two great theories of physics has a name: the black hole information paradox. It is a crisis that has haunted theoretical physics for half a century. The rules of quantum mechanics are built on a foundation of perfect preservation. Information, the unique quantum identity of every particle, can never be truly erased. It can be scrambled, transformed, but never destroyed. Think of burning an encyclopedia. The paper and ink turn to ash and smoke, but a hypothetical superintelligence could, in principle, collect every particle of soot and trace of heat to reconstruct the exact text on every page. The information is chaotically transformed, not lost. A black hole was thought to be different, the universe's ultimate shredder. According to classical general relativity, when anything crosses the event horizon, it is irretrievably gone. Its information is lost forever, seemingly violating a sacred law of quantum physics. This is the paradox in its starkest form. Stephen Hawking himself discovered a mechanism that makes the problem even more acute. He realized that black holes are not entirely black. Due to strange quantum effects at the very edge of their event horizons, they slowly emit a faint glow of radiation. This Hawking radiation carries energy away from the black hole, causing it to gradually shrink and, over eons, evaporate completely. The terrifying implication was that the black hole could vanish, leaving no trace of the immense amount of information it ever swallowed. The cosmic shredder had not only destroyed the documents, it had then burned itself to ash, leaving no record behind. This suggests a universe where history can be fundamentally erased, a notion that most physicists find deeply unsettling. So where does the information go? If it is not destroyed, it must be encoded somewhere. Proposed solutions are as mind-bending as the paradox itself. Perhaps the information is not lost inside the black hole, but is somehow smeared across its event horizon, imprinted on the Hawking radiation as it leaks out. Maybe the information is transferred to another universe or a different part of our own. Each potential solution forces us to question the most basic assumptions about reality. It hints that our understanding of spacetime and locality, the idea that objects can only be influenced by their immediate surroundings, is profoundly flawed. This paradox is not just a technical puzzle. It is a glaring signal that to find the truth, we may have to rethink the most fundamental flow of time itself, questioning whether the future is truly as open as it seems. This revolutionary idea finds its roots in the ultimate information traps, black holes. Physicists studying these cosmic voids made a startling discovery. The amount of information, or entropy, a black hole can contain is not dictated by the vast volume of space inside it. Instead, it is precisely proportional to the surface area of its event horizon. It is as if all the data describing every star, planet, and atom that ever fell in is painted onto the black hole's two-dimensional spherical surface. The three-dimensional interior we imagine is just a projection, a decoded image from that data. The holographic principle boldly applies this logic to the entire cosmos. The universe we perceive, with its immense galaxies and seemingly infinite space, might be a grand illusion. All the information needed to describe every event, every particle, every thought within our cosmic horizon could be encoded on the two-dimensional surface of that horizon itself. Think of a hologram on a credit card. The flat, shiny surface contains no depth, no real objects, yet when light hits it the right way, it projects a stunningly realistic three-dimensional image. The holographic principle suggests our reality is that projection. The true, fundamental workings of the universe are written on a distant, flat surface we can never touch. The three-dimensional world of height, width, and depth that we move through is a magnificent translation of that underlying code. This is not just a philosophical curiosity. It drastically simplifies the fundamental building blocks of reality. In a three-dimensional world, the number of ways things can be arranged seems limitless. But if everything is encoded on a two-dimensional screen, the total information is finite, limited by the number of tiny pixels or Planck areas on that surface. This provides a potential bridge to unify the warring theories of general relativity and quantum mechanics by describing gravity and particles in the same, simpler language of information on a boundary. It sets the stage for a cosmos where nothing is quite as it seems, where the solidity of the present moment might be written from a source we have not yet considered. Our ability to predict the past far outstrips our power to foresee the distant future. We gaze at the faint, cold glow of the cosmic microwave background, the ancient light from the universe's infancy, and from that single snapshot we can rewind the cosmic film with breathtaking precision. We can calculate the exact temperatures, the tiny density fluctuations, the initial conditions that existed just moments after the Big Bang. This power, known as retrodiction, is unnervingly effective. It feels as though the universe's opening chapter was written with a singular purpose, perfectly calibrated to produce the galaxies, stars, and planets we see around us today. Why is the past so clear and deterministic, while the future remains a fog of quantum probabilities and cosmic uncertainties? The initial state of the cosmos appears to be exquisitely fine-tuned. If the force of the Big Bang had been even slightly stronger, matter would have flown apart too rapidly for galaxies to ever form. If it had been marginally weaker, gravity would have pulled everything back into a catastrophic collapse long before life could emerge. This is not a minor adjustment. It is like a cosmic lottery where the odds of winning are 1 in a number with more zeros than all the atoms in the visible universe. Such precision defies simple chance. It hints at a deeper logic at work. One provocative explanation is that this fine-tuning is not a random starting point, but a necessary consequence of the universe's final state. The present we inhabit, with its specific structure and complexity, may be actively reaching backward in time, selecting the one and only past that could have possibly led to its own existence. The clear, defined story of our history might be written not from its beginning but from its end. This unidirectional flow of time from a clear past to an uncertain future is the second major clue. We all intuitively understand the arrow of time. You watch a drop of ink disperse in a glass of water, creating a uniform, murky mixture. You never see that murky water spontaneously gather itself back into a single, neat drop of ink. A shattered vase lies in pieces on the floor, its ordered structure gone, replaced by chaotic fragments. It does not leap from the floor and reassemble itself. This relentless march from order to disorder is driven by a property called entropy, a measure of the universe's randomness. This is the thermodynamic arrow of time, and it feels as fundamental as gravity. Yet when we peer into the pristine equations of physics, from Newton's laws to Einstein's relativity and even quantum mechanics, we find a profound mystery. These laws are almost perfectly time-symmetric. A film of two planets orbiting a star would look completely natural if run backward. A video of a single electron would be indistinguishable in reverse. The fundamental rules do not care which way time flows, so why does our reality exhibit such a powerful, one-way bias toward disorder? The conventional explanation points a finger back to the very beginning, to the Big Bang. It states that our universe just happened to start in a state of incredibly low entropy, a condition of exquisite order, and has been unraveling ever since. But this only pushes the mystery one step further. Why was the initial state so ordered? A low entropy beginning is astronomically improbable, like shuffling a deck of cards and finding it perfectly organized by suit and number. This is where the plot thickens with a truly radical proposition. Perhaps the arrow of time is not launched from the past but pulled from the future. The reason the Big Bang was in such a specific, low entropy state is because that was the only starting point consistent with the universe's ultimate final state. The future destiny of the cosmos, perhaps a state of maximum entropy or a specific final configuration, is what actively selects the past that must lead to it. In this view, the clear, deterministic history we can so easily retrodict is not a record of what was, but a necessary consequence of what will be. The thermodynamic arrow of time is not a fundamental rule of the cosmos, but an emergent illusion, a story written backward from a final chapter we have not yet reached. The third and perhaps most baffling clue comes from the quantum realm, a domain where logic itself seems to unravel. Quantum mechanics is famous for its bizarre rules, but the strangest of all might be the delayed choice experiment. This is not just a thought experiment, it has been performed in laboratories with undeniable results. In these tests, physicists can set up a photon, a single particle of light, to travel along a path where it has a choice. It can behave as a compact particle, taking one definite route, or as a spread-out wave, taking multiple paths simultaneously. The truly mind-bending part is that the experimenter can delay the decision of which property to measure until long after the photon has already finished its journey and should have made its choice. Astonishingly, the measurement made in the present appears to reach back in time, dictating whether the photon traveled as a particle or a wave in the past. It is as if the photon's history remains fluid, a collection of potential stories, until the final observation locks one of them into place as reality. This directly challenges our deepest assumptions about cause and effect. It suggests that the future, in the form of a conscious decision to look, can reach back and sculpt the past. While physicists debate what this truly means, the phenomenon of quantum retrocausality offers a tantalizing hint. Information and causation might not flow in a single, irrevocable direction from past to future. The universe's script might be written with feedback from its final act. This is not some small-scale curiosity confined to a lab. The principles of quantum mechanics underpin everything, and some physicists propose that the entire cosmos could be subject to a version of this delayed choice. The universe itself may be waiting for its own final measurement, its ultimate future, to fully determine the story of its own beginning. This idea that the future could reach back to shape events finds a startling echo in a classic, if controversial, theory from the last century. The Wheeler-Feynman absorber theory was crafted to solve a specific puzzle in electromagnetism. Why does an accelerating charged particle, like an electron being jiggled, radiate energy outward as light? The conventional answer is simple: the particle just does. But John Wheeler and Richard Feynman proposed a far more radical explanation. They suggested the particle radiates because of a kind of cosmic consensus reached across all of time. In their view, when an electron accelerates, it sends out signals not just into the future, but also advanced waves backward into the past. These waves travel through time, interacting with every other charged particle in the universe, both those in its future and its past. The particles in the future, the absorbers, then send a response rippling back through time to the original electron. The radiation we ultimately observe and measure is the result of this complex, self-consistent handshake between the source and the entire universe, a transaction that seamlessly links cause and effect across the entire timeline. This theory paints the cosmos not as a stage where events play out in a strict sequence, but as a single, complete, and perfectly interwoven system. Every action is a response, and every cause is also an effect, with the future playing as active a role as the past. For the thinkers behind it, this was more than just a clever fix. It was a philosophical stance on the nature of physical law. The universe had to be consistent, and that consistency required the future to be just as real and influential as the past. While the Wheeler-Feynman theory eventually fell out of the mainstream, overshadowed by other approaches in quantum electrodynamics, its profound philosophy did not fade away. It demonstrated that time-symmetric physics, where the flow of time loses its privileged direction, is a perfectly coherent and elegant possibility. It stands as a powerful precursor to the modern, mind-bending suspicion that our reality might indeed be a story being written from its final page. This transactional view of reality gives us a tangible model for how the future might speak to the past. Proposed by physicist John Cramer, the transactional interpretation of quantum mechanics frames every particle interaction as a kind of negotiation across time. Imagine you want to make a purchase from a distant shop. You first send an order form, an offer. The shop receives your offer and sends back a confirmation, finalizing the sale. In Cramer's universe, quantum particles do something eerily similar, but the mail service operates through time itself. When a quantum event is set into motion, like a photon heading toward a detector, it sends out what Cramer calls an offer wave. This wave travels forward in time, exploring all possible paths to every potential future. When it encounters a detector, a device that will ultimately measure it, that detector in the future responds. It sends a confirmation wave backward in time, retracing the path of the original offer. It is only when this loop is closed, when the handshake between the past emission and the future absorption is complete, that a specific outcome becomes real. The photon's path, its location, its very existence as a particle or a wave, is not decided until this transaction is confirmed. This provides a stunningly intuitive picture for the baffling delayed choice experiment. The reason a photon's past seems fluid is because it literally is. Its history remains an open offer until a future detector sends the confirmation wave that locks in its story. The past is not a fixed, unchangeable record. It is a set of possibilities waiting for a final confirmation from what is to come. In this framework, the flow of time is not a one-way river. It is a two-way street, a constant dialogue. The present moment we experience is not the leading edge of creation. It is more like a clearinghouse, a nexus where waves from the past and waves from the future continuously converge, their interactions crystallizing into the solid reality we perceive. While this interpretation is not the mainstream view in physics, it provides a formal, mathematical framework for a cosmos that is not pushed from behind by its initial conditions, but pulled into being by its ultimate destiny. It suggests a universe where the future is not a blank page, but an active author, helping to write the very history that leads to its own existence. This philosophical idea that a final goal can shape events has a name: final causality. More than 2,000 years ago, the philosopher Aristotle outlined 4 different kinds of causes that explain why things are the way they are. There is the material cause, the stuff something is made of, like the marble of a statue. There is the formal cause, its shape or design, the blueprint of the statue. Then there is the efficient cause, the immediate action that brings it about, the sculptor's chisel striking the stone. But the fourth cause, the final cause, is the most intriguing. It is the purpose, the end goal, the reason for which the statue was carved in the first place. For centuries, modern science has operated as if only the efficient cause matters. It asks what force pushed an object, what prior event triggered a reaction, tracing a chain of causes backward into the past. The idea of a future purpose influencing the present was dismissed as unscientific, a relic of mystical thinking. But the cosmic puzzles we face are forcing a dramatic reconsideration. The universe's unnervingly low entropy beginning, its precise fine-tuning for complexity, and the strange way future horizons seem to limit past possibilities all point to a startling conclusion. Perhaps the universe itself has a final cause. This is not a conscious intention or a divine plan. It is a mathematical boundary condition, a specific state the cosmos must reach in its far future. This ultimate final state acts like a powerful attractor, a gravitational pull not through space, but through time itself. It reaches backward across the ages, ensuring that only those possible histories which are consistent with its own eventual reality can ever truly unfold. From the infinite sea of potential beginnings, only the one that leads to this specific end is selected. The Big Bang was so perfectly ordered because any other starting point would have been inconsistent with the universe's ultimate destiny. This reintroduces the concept of teleology, the study of ends and purposes, into the heart of physics. It is a sophisticated mathematical teleology where the future does not consciously plan, but simply exists as a fixed point, and its sheer existence dictates the entire story that must lead to it. This idea of a future-pulled reality leads us directly to one of the most famous thought experiments in all of science fiction. What if you traveled back in time and prevented your own grandfather from meeting your grandmother? You would never be born, making your time travel and your meddling impossible. It is a perfect logical contradiction, a paradox that should shatter the very fabric of cause and effect. Yet if the future truly codes the past, how do we avoid such cosmic nonsense? The answer lies in a profound physical principle, the principle of self-consistency. The universe does not permit paradoxes, it simply forbids them. This means that out of all the infinite possible sequences of events, only those histories that form a single, perfectly consistent loop from the first moment to the last can ever become real. The cosmic timeline is not a straight line that can be twisted into a knot. It is a closed, self-consistent circle where every event is both the cause of future events and a necessary effect of the final state. Imagine a master novelist who has already written the final chapter of an epic book. The ending is fixed, immutable. Now the writer goes back to draft the opening chapters. They cannot introduce a character or a plot point that would contradict the predetermined conclusion. If the hero is destined to triumph in the final battle, the writer cannot have him die in an unimportant skirmish halfway through the story. That event is simply not allowed. In our universe, the final cosmic state is that last chapter. It acts as a universal editor, a constraint that reaches back across all of time. Any event that would create a logical inconsistency with that final state is physically impossible. A time traveler could not kill their grandfather, not because some cosmic god would stop them, but because the very attempt would be thwarted by a seemingly random sequence of events, a missed train, a sudden change of heart, a universe conspiring through sheer probability to ensure its own story remains coherent. This transforms our view of reality from a flowing river into a single, four-dimensional sculpture. The past, present, and future all coexist as parts of this immutable block. The feeling of moving through time is the illusion, a consciousness reading the book one page at a time, but the book itself is complete. The future does not create the past out of nothing. Instead, the entire history of the universe is a single, self-consistent truth, where the final condition and the initial condition are in perfect, harmonious agreement. The Big Bang was not a random explosion. It was the only possible beginning that could lead to this specific, inevitable end. This line of thinking leads to an even deeper question, one that strikes at the very foundation of reality. Could the fundamental laws of physics themselves, the immutable rules that govern everything from atoms to galaxies, be a consequence of the universe's final state? We take for granted that the speed of light, the strength of gravity, and the mass of an electron were set in stone at the moment of the Big Bang. But what if they were not fixed at the beginning, but are instead a flexible, emergent property, selected by the cosmic finale? The anthropic principle offers one perspective, suggesting we observe these specific constants simply because a universe with different values would not have allowed for stars, planets, or observers like us to arise. Yet this feels like an explanation of last resort, a selection effect on an infinite multiverse where every possible set of laws plays out somewhere. A far more radical idea is that within our single universe, the laws are not the starting point, but the end result. In some approaches to quantum gravity, the very fabric of spacetime is not a fixed stage. Its geometry and even its topology, its fundamental shape, can fluctuate and change. The laws of physics as we know them, from electromagnetism to nuclear forces, may not be fundamental. Instead, they could be effective laws that emerge from a cosmic average, a sum over all possible histories that the universe could have taken. This is where the future boundary condition exerts its ultimate influence. The specific final state of the cosmos, whether it collapses into a fiery big crunch, slowly evaporates into darkness, or reaches a silent heat death, could act as a cosmic filter. It would heavily weight this sum over histories, favoring only those timelines whose physical laws are perfectly tuned to produce that one specific destiny. The strength of gravity, the number of spatial dimensions, the very existence of matter itself, all could be downstream of the end. In this breathtaking view, the laws are not the cause of the universe's story. They are a consequence of its final chapter, an emergent property of a timeline that is consistent from its first moment to its last. The universe does not obey laws, it grows them, guided by the silent, persistent pull of its own inevitable future. The Big Bang suddenly looks less like a beginning and more like an opening sentence. If the cosmos is indeed authored from its finale, then that first fiery moment was not a random, lawless explosion. It was the only possible first step, the necessary prologue for a universe destined to become the one we inhabit. Its defining characteristics, the very things that have puzzled cosmologists for decades, start to make a new kind of sense. Consider the horizon problem. We look out in opposite directions in space and sea regions of the cosmos that are billions of light years apart. Yet these vastly separated areas have almost exactly the same temperature and density. According to standard physics, these regions could never have been in contact with each other, not even in the earliest moments. They are like two strangers living on different continents who somehow know the same secret handshake. The prevailing solution has been cosmic inflation, a brief period of unimaginably rapid expansion that smoothed everything out. But what if inflation itself was not the root cause? What if the smoothness was a prerequisite? If the future state of the universe required a long, stable evolution filled with galaxies and stars, then it could only tolerate a past that was smooth enough to allow for that future. A chaotic, lumpy Big Bang would have led to a quick collapse or a violent tear, a story cut short. The ending demanded a coherent beginning. This future coding principle also illuminates the profound mystery of the universe's low entropy. The early cosmos was in a state of astonishingly high order, a perfectly smooth soup of particles. This is the ultimate free lunch, the reason time has an arrow. But from the future first perspective, this was not a lucky accident. It was a logical necessity. A high entropy, disordered beginning would have been a dead end, a universe that achieved its final state of maximum randomness almost instantly. The complex, structured cosmos we see around us, with its swirling galaxies and intricate chemistry, could only emerge from a past of exquisite, improbable order. That order was not a gift from the beginning. It was a loan from the end, a necessary investment to build a universe rich enough to eventually produce its own final chapter. The Big Bang, in this light, becomes the first domino to fall in a chain that was already completely arranged, the initial note of a symphony whose final chord was already resonating backward through time, tuning the very first instrument. This brings us to the second profound implication, the nature of dark energy itself. We have identified this mysterious force as the engine behind the universe's accelerating expansion, the very thing crafting our ultimate cosmic shadow. Yet its most baffling feature is its value, a number so precise it defies all logic. The energy density of the vacuum is astonishingly small, but not zero. If it were even slightly larger, the repulsive force would have been so powerful that it would have torn galaxies, stars, and even atoms apart in the universe's infancy, preventing any structure from ever forming. If it were marginally smaller, the attractive pull of gravity would have overwhelmed the expansion long ago, dragging the entire cosmos back into a fiery big crunch. For a universe like ours to exist, with its long, stable history and rich tapestry of galaxies, the value of dark energy had to be calibrated with a precision that is almost beyond comprehension. It is like tuning a radio dial to one specific station across the entire static-filled band of possibility, and somehow landing on it by pure chance. The odds are so astronomically low that many physicists reject coincidence as an explanation. A universe coded from its future, however, offers a compelling solution. In this model, the value of dark energy is not a random number set at the beginning. It is a necessary parameter, a dial that had to be set exactly to this position for the cosmos to reach its intended final state. That ultimate destination, which many cosmologists identify as a de Sitter space governed by a specific cosmological constant, acts as a powerful selector. It demands a particular evolutionary history, a specific timeline where structures can form and persist for billions of years, which in turn locks in the apparent value of dark energy we measure today. The force that is actively shaping our cosmic future is in a perfect loop, reaching back to determine the fundamental energy content of our past. The shadow that defines the edge of our reality is not just a passive boundary, but an active participant in its own creation. Information is the one currency the cosmos cannot afford to lose. In a universe authored from its finale, nothing is ever truly erased. It is simply translated into a different language. This resolves the deepest fears of the black hole information paradox, the terror that reality might have a cosmic shredder. When a book, a planet, or an entire star crosses a black hole's event horizon, its information does not vanish into a singularity of nothingness. According to the holographic principle, the data describing that object is immediately smeared and encoded across the two-dimensional surface of the event horizon itself, like intricate ink on a vast spherical page. The three-dimensional reality inside the black hole is just a projection of that data, a decoded image. But what happens when the black hole itself slowly evaporates, fading away through the faint whisper of Hawking radiation? The information is not destroyed. It is meticulously imprinted onto the radiation itself, a final, subtle translation. The Hawking radiation is not random noise, it is a complex message, a detailed record of everything that ever fell in. The black hole's entire life and death are a single, self-contained information processing cycle, and its final state, its complete evaporation, is the event that guarantees the preservation of that data. The future fate of the black hole, its disappearance, is what locks in the story of its past. This logic scales up to the grandest horizon of all. When a distant galaxy recedes beyond our cosmic event horizon, vanishing from our future view, it feels like a permanent loss. From our local perspective, it is gone, but from the global perspective of the universe's complete four-dimensional timeline, that information has not been erased. It remains an integral part of the self-consistent whole, forever encoded on the boundary of that cosmic shadow. The galaxy's story is still written on the ultimate DVD of our holographic universe. It is just a chapter we, from our limited vantage point, can no longer read. The paradox of lost information melts away when we realize the final answer. The state of the universe at the end of time has always contained every single bit of data. This ultimate boundary condition acts as a cosmic librarian, ensuring that no volume is ever misplaced. It constrains the entire history of the cosmos, from the first instant to the last, to be perfectly consistent with the complete and total preservation of information. The future does not create the past, it conserves it. This paints a picture of reality as an indestructible, immutable whole, where every event, every particle, and every thought is eternally safeguarded within the finished sculpture of spacetime. What does this unbreakable conservation of information mean for the nature of our own consciousness and the reality we perceive moment to moment? A profound question now emerges from this cosmic architecture. If the entire timeline is a single, self-consistent block, where does that leave our own sense of free will? The idea that your future is already out there, actively shaping your past, feels like it shatters the very foundation of personal agency. It conjures the image of a cosmic puppet master, pulling strings from a destination we cannot see, rendering our every decision a mere illusion. Yet this perspective may not destroy free will, but rather transform our understanding of it into something far more integrated with the cosmos. Your conscious experience is not a passive reading of a pre-written script. It is the dynamic, local unfolding of that script itself. Your reasoning, your deliberations, your hopes, and your fears, these are not side effects. They are the very computational process through which the universe ensures its own global consistency. Think of a magnificent, self-writing novel. The final chapter is fixed, but the journey to reach it is filled with rich character development, complex choices, and genuine suspense. The hero's decisions are not fake, they are absolutely essential. Without them, the story could not reach its predetermined conclusion. In the same way, your choice to watch this video, to learn, to question, is a necessary and real part of the causal chain that leads to the universe's final state. Your will is not an illusion, it is a fundamental component of the cosmic code. The feeling of weighing options and making a choice is the local, moment-to-moment experience of the universe's global self-consistency playing out within your mind. Your life, with all its triumphs and tragedies, is the vital narrative that connects the coded beginning to its destined end. You are not a spectator in this cosmos. You are an active participant in its grand, self-authoring story. This profound silence from the cosmos might be the loudest clue of all. For decades, the Fermi paradox has echoed through our search for other minds, a simple, devastating question. If the universe is so vast and so old, where is everybody? We scan the skies for radio signals, for megastructures, for any sign we are not alone, and we are met with an unnerving cosmic quiet. The future coding hypothesis casts this great silence in a startling new light. The ultimate destiny of our universe, that cold, empty heat death, could be acting as a cosmic editor. It is not just selecting for a past that leads to a stable cosmos, but it may be actively selecting against any history that includes widespread, galaxy-spanning intelligence. The final state of solitude seems to prefer a past that is equally lonely. The universe's code might be written in such a way that the emergence of intelligent, spacefaring life is an astronomically rare fluke. Or, more chillingly, the code might contain a fatal bug, a built-in tendency for intelligence to inevitably lead to its own destruction through war, environmental collapse, or some other technological trap we have not yet encountered. There is another, more enigmatic possibility. Perhaps intelligent life does not die out but consistently transcends. It might evolve beyond the crude, materialistic need to build radio beacons and star-spanning empires, uploading its consciousness into substrates or dimensions we cannot perceive or communicate with. This would create a universe filled with invisible, post-biological ghosts, leaving no trace for a fledgling species like ours to find. The great filter, the hypothesized barrier that prevents life from becoming common across the galaxy, may not lie in our past. It might not be the difficulty of forming the first cell, or the rise of multicellular life, or the development of tool use. The filter could be waiting for us in the far future. The final, silent state of the cosmos could be reaching back through time, pruning away any potential timeline where intelligence becomes a noisy, galactic constant. It ensures that only histories leading to a quiet end are permitted to become real. We might be alone, not because life is impossible, but because a universe that ends in perfect, profound silence cannot have a past that was ever truly loud. The eerie quiet of the night sky is not a puzzle to be solved, but a feature of the cosmic design, a necessary consequence of the story's final, solitary page. So how do we test an idea that questions the very flow of time itself? Direct proof is a monumental challenge, but science thrives on finding indirect, clever pathways to truth. One promising route lies in the oldest light we can see, the cosmic microwave background. This faint afterglow of the Big Bang is a cosmic fossil, and we have mapped its tiny temperature fluctuations with exquisite detail. If the universe's future state is truly reaching back to shape its infancy, it might have left a subtle signature in this ancient radiation. Perhaps there are patterns, specific correlations or anomalies in the way these temperature variations are arranged that cannot be explained by any process starting from the past alone. These could be the cosmic equivalent of finding a watermark from the future imprinted on the first page of time. Another key testing ground is the nature of dark energy and the cosmic event horizon it creates. If the value of dark energy is not a random initial condition but a necessary parameter for the universe's final form, then its precise behavior might hold clues. As we gather more data from powerful telescopes observing the large-scale structure of the cosmos and the acceleration of expansion, we might find that the properties of dark energy fit more naturally into a model with a final boundary condition than one with only an initial one. The cosmic shadow itself, the de Sitter horizon, could have quantum properties that reveal its active role in structuring reality from the future inward. Back on Earth, we can push the limits of quantum weirdness. The delayed choice experiment has already shown that a photon's past is not fixed until it is measured. The next step is to scale this up. What if we perform a delayed choice experiment not with a single photon, but with a large molecule, or eventually an object composed of billions of atoms? If these larger, more complex systems continue to show that their history is malleable based on future measurements, it would dramatically strengthen the case for retro-causality. It would suggest that the future's influence is not a tiny quantum quirk, but a fundamental feature of reality that scales all the way up. Furthermore, if the future is actively coding the past, we might discover strange, non-local correlations in data that defy standard cause and effect chains. In vast astronomical surveys or even in carefully controlled particle accelerator data, scientists could search for statistical patterns where events seem to be coordinated not by a common cause in their past, but by a shared outcome in their future. Finding such a signature would be like discovering that the final chapter of a mystery novel is somehow responsible for arranging all the clues in the opening pages. Ultimately, the most compelling evidence may come from a theory that unites quantum mechanics and gravity. Any successful theory of quantum gravity must solve the black hole information paradox and explain the universe's low entropy beginning. A formulation that naturally and elegantly incorporates a final boundary condition where the end of time is as important as the beginning would be a monumental achievement. It would not just be a mathematical curiosity, it would be a framework that makes these bizarre cosmic puzzles suddenly click into place. The quest to find these fingerprints of a future-pulled reality is now one of the most daring and profound challenges facing modern physics, a search for echoes from the end of time in the data we collect today. Such a radical rewriting of time's arrow does not go unchallenged. A primary and powerful criticism comes from our deepest intuition. The notion that a future event can influence the past feels like a direct assault on the logic of cause and effect. It seems to invite paradoxes, creating a world where a fire could start because a forest is destined to burn, a universe where reasons follow their results. Many physicists argue that without a fully developed, mathematically rigorous framework, these ideas remain in the realm of philosophical speculation. The block universe, where past, present, and future are equally real, is a compelling picture, but critics point out it is just that, an interpretation. It does not, in its current form, make unique, testable predictions that differentiate it from standard cosmology with its initial conditions. There is also the risk of a tautology, a circular argument that explains nothing. Saying the universe is fine-tuned because it leads to a future that required fine-tuning can feel like saying a book exists because it has a last page. This does not explain why this specific book was written, why this particular future, despite these formidable objections. The very existence of such a fierce debate is a symptom of a deeper crisis in our understanding. Classical model of a universe born from a random, low-entropy state leaves us with questions so profound they border on the philosophical. Why that state? Why these laws? The sheer improbability of our cosmic starting point is a glaring anomaly that standard models struggle to address without resorting to the multiverse, an idea that is itself notoriously difficult to test. The puzzles of quantum non-locality and the black hole information paradox are not minor quirks. They are fundamental fractures in our understanding of reality. When the existing map of physics contains such glaring blank spots, we are compelled to consider even the most counterintuitive paths to fill them in. Exploring the possibility of a future-coded universe is not an abandonment of scientific principles. It is an embrace of them, a recognition that when nature presents us with paradoxes, the solution may require us to question our most basic assumptions, even the direction of time itself. This intellectual tension is not a weakness, it is the engine of scientific progress, forcing us to sharpen our theories and look at the cosmos with fresh, if unsettled, eyes. We are left standing before a universe that no longer resembles a clockwork mechanism, the Newtonian dream where a single push from the past sets every gear in motion for all time, shatters against this new vision. Time is not a chain of falling dominoes. It reveals itself as a vast, interconnected web where every strand pulls on every other, and the final knot constrains the very first thread. This is a cosmos of mutual constraint, a single, timeless tapestry where the beginning and the end are in constant, silent dialogue. This perspective finds a startling echo in ancient Eastern philosophies, particularly the Buddhist concept of dependent origination. This is the profound understanding that all phenomena arise together in a mutually interdependent web of cause and condition. Nothing exists in isolation, everything is connected, and the nature of reality is this very network of relationships. In our cosmic context, the future is not an isolated effect, but a powerful condition for the past, a fundamental part of the interdependent web that brings the entire universe into being. This forces a radical reassessment of what reality actually is. Are we living inside a vast, ongoing computation where the universe is the output of a cosmic algorithm running to its final line of code? Is it a grand, self-writing story where the plot is not linear but woven from a predetermined ending? Or is it, as some physicists suggest, a pure mathematical structure, a set of eternal relationships and forms that simply are? The idea that the future codes the past blurs the boundary we thought was firm, the line separating physics from metaphysics, the ultimate explanation for why anything exists at all, for why the laws are as they are, may not be found by digging backward to a first cause, a prime mover who lit the fuse. Instead, the answer may be waiting for us at the end of everything, in a final cause that has been silently guiding the entire unfolding from its destination. We are invited to see our own lives, our struggles and our joys, not as fleeting moments on a one-way street, but as integral, necessary threads in this grand, timeless pattern. Our story was always part of the whole tapestry, its meaning forever intertwined with the final, beautiful design. This brings us to the enigmatic role of the observer, the conscious mind that perceives this cosmic dance. In a universe authored from its future, the strange act of quantum observation becomes something more than a mere measurement. It transforms into a crucial nexus, a moment where the confirmation wave from the future meets the offer wave from the past, their handshake crystallizing a specific event into tangible reality. Your act of looking, of questioning, is not creating the world from nothing. Instead, it is the essential process through which the universe's single, self-consistent timeline is locally experienced and made concrete. Consciousness, in this view, is not a ghost in the machine. It is the medium, the dynamic interface through which the global, timeless truth of the cosmos is translated into a linear, moment-to-moment narrative. Your stream of thought, flowing from one second to the next, feels like a journey into the unknown. Yet it may be the local manifestation of a vast global process, a computation that integrates the entire four-dimensional block of spacetime. Your sense of a moving present is the way this immense, atemporal structure feels from the inside. This does not make consciousness supernatural or separate from the physical world. It is an emergent property of a brain, a complex biological system operating under these profound temporal constraints. Your mind is a localized region where the universe's need for global consistency is being actively worked out, where possibilities are narrowed into the single, coherent story you live. You are not a passive spectator watching a film unfold. You are an active participant in the projection of the film itself, your conscious awareness the very light that illuminates the screen, making the encoded data of the cosmos manifest as your vivid, personal reality. The holographic universe carries a startling implication, one that bridges ancient philosophy and modern computing. If our three-dimensional reality is merely a projection from a two-dimensional boundary, and the data on that boundary is set by the universe's final state, then the cosmos begins to resemble a grand simulation. This is not a literal claim that we live inside a machine built by advanced programmers. It is a powerful analogy that helps us visualize how a future-coded reality might actually function. Think of a sophisticated computer model designed to predict the climate. A scientist does not simply input random starting conditions and hope for the best. Instead, they define the desired outcome, a specific global temperature or atmospheric composition a century from now. The computer then works backward, calculating the only possible set of initial weather patterns, ocean currents, and greenhouse gas levels that could logically lead to that predetermined future. In this model, the final result is not the output, it is the input. The simulation's entire history is reverse-engineered from its goal. Our universe could be operating on a similar cosmic scale. The final, cold, silent state of maximum entropy acts as the target outcome. The laws of physics as we know them, the strength of forces, the mass of particles, are not the foundational code. They are the emergent rules that the system must follow to ensure a perfectly self-consistent journey from the Big Bang to that specific end. The cosmic code is not software written in silicon, but the immutable mathematical logic of boundary conditions and self-consistency. This analogy transforms the seemingly mystical idea of a future authored past into something we can almost grasp. The universe is not being run from start to finish like a movie. It is being optimized from finish to start, with every event in between constrained by the need to reach a single, inevitable destination. The smoothness of the Big Bang, the value of dark energy, even the eerie silence of the cosmos are not random features. They are the necessary initial parameters and runtime rules for a universe destined to become what it will be. This static sculpture of spacetime is known as the block universe. Within its four-dimensional expanse, the past, the present, and the future do not come into being and then fade away. They simply are. They exist eternally, fixed in their place within the grand structure, much like different pages in a book that has already been written. In this view of eternalism, there is no privileged moment we can call now. Your birth, your life, and every event in the distant future of the cosmos are all equally real, just as real as the chair you are sitting on. The feeling of a flowing present is not a feature of the universe itself, but a feature of our consciousness, a subjective experience as we journey through the frozen landscape of the block. This resolves the most troubling paradox of a future-coded past. We are not dealing with a cause leaping backward through time, because in the block universe, there is no backward or forward in the ultimate sense. All moments are equally present. The future does not reach into the past. Instead, the entire block is shaped by its boundaries, by the conditions set at its beginning and its end. The final state of the cosmos is not a destination in time, but a fixed feature of the entire structure, a global constraint that ensures every part of the timeline is logically consistent with every other part. The universe is not a chain of causes, but a single, interlocked truth. The reason the Big Bang was so perfectly ordered is not because something reached back, but because any other starting point would have been inconsistent with the fixed, final page of the cosmic story. Your own life, with all its choices and chances, is not a script being written as you go. It is a beautiful, intricate thread already woven into the complete tapestry. The feeling of free will, of making a genuine choice, is your conscious experience of following that thread, of living the story that was always there. The flow of time is the turning of the pages, but the book itself is complete. To build a universe from its future, we need more than a philosophical sketch. We require the hard scaffolding of mathematics. One of the most promising blueprints comes from a cornerstone of quantum theory, the Feynman path integral. In this stunning formulation, a particle traveling from point A to point B does not take a single, well-defined route. Instead, it simultaneously explores every conceivable path, every possible trajectory through space and time. The reality we observe is the ghostly sum, the interference pattern of all these potential journeys. Now inject the idea of a future authored cosmos. This mathematical sum would no longer be a free-for-all. It would be rigorously constrained. We would only add up those paths, those possible histories, that are logically consistent not just with the particle's starting point, but with its predetermined final destination as well. The particle's entire history is filtered through its inevitable future, with only the self-consistent stories making the final cut. This concept already has a foothold in the most ambitious attempts to describe the Big Bang itself. Proposals like the Hartle-Hawking no-boundary idea use a similar approach to define the universe's birth, picturing the beginning of time as a smooth, rounded edge without a singular point. Yet this model primarily applies a boundary condition only at the start. A truly future-inclusive cosmology would demand a second, equally important boundary, a mathematical specification of the cosmos's final state. The universe would be a single, seamless computation that is pinned at both ends. Another powerful framework emerges from quantum information theory, which treats reality as a vast, evolving quantum circuit. In this digital-like view of physics, the most fundamental operations are not necessarily one-way. Time-symmetric processes where cause and effect loops back on itself could be a primitive feature of the cosmic code. The universe would not compute from past to future, but would instead resolve a grand, self-consistent equation where the output and the input are inextricably linked. Developing the full mathematics for these ideas is the monumental task now facing theoretical physicists. It is the crucial work of translating a mind-bending possibility into a concrete, predictive, and ultimately testable theory of everything. Two particles born from the same event and then flung to opposite ends of the galaxy remain locked in a mysterious embrace. Change the spin of one, and its partner instantly reflects that change, no matter the light years between them. This is quantum entanglement, a phenomenon Einstein famously called spooky action at a distance. It reveals a deep and baffling non-locality in the universe, a connection that operates outside the speed of light, weaving space together with threads we cannot see. But what if this spookiness is not confined to space alone? If particles can be correlated instantly across a distance, perhaps they can also be correlated across time. This is the radical idea of temporal non-locality. It suggests that events in the future could be just as intimately linked with events in the past as two entangled particles are linked across a room. In the transactional interpretation we explored earlier, this is exactly what is happening. The offer wave and the confirmation wave form a single, non-local entity that spans time, a handshake between the future and the past. The cosmic shadow, that ultimate horizon, might represent the fundamental limit of these non-local connections. It could be the boundary beyond which this temporal entanglement cannot reach, the edge of the cosmic web. This implies a staggering possibility. The final state of the universe, that cold, silent destiny at the end of time, could be quantum entangled with its own fiery beginning. They are not separate events, but two parts of a single, unified whole, forever correlated across the entirety of cosmic history. The Big Bang and the heat death are like two entangled particles, their fates inseparably linked, defining each other in a single, timeless correlation. This deep link between spatial and temporal non-locality may be the master key to the cosmic code. The strange, instantaneous connections we see in the quantum realm could be the local, spatial expression of a much grander, temporal connection that binds the entire timeline of the cosmos into one consistent, self-realizing story. The universe is not just non-local in space, but in time as well, a single, coherent entity written all at once, from its first whisper to its final, silent breath. Our very existence becomes a powerful clue written into the cosmic code. The anthropic principle has long been a curious footnote in cosmology, suggesting we observe a universe fine-tuned for life simply because in a lifeless one, there would be no one to do the observing. It can feel like a tautology, a cosmic shrug of the shoulders, but when viewed through the lens of a future authored reality, this principle transforms into something far more profound. It is not merely that we lucked out in a cosmic lottery of infinite universes. Instead, our presence here and now is a necessary, non-negotiable part of the story. The universe's final state did not just permit a past where life could accidentally arise. It demanded it. The timeline is a single, self-consistent loop, and our conscious observation is a crucial node within that loop, a fixed point that the entire history must accommodate. We are not accidental tourists in a vast, indifferent cosmos. We are integral characters, and the plot simply could not unfold as written without us. This means the specific laws of physics, the value of dark energy, and the low entropy of the Big Bang are not just happy accidents that allow for observers. They are the direct consequences of a cosmic narrative that requires observers to complete its final, self-consistent form. Our act of looking at the stars, of measuring the cosmic microwave background, of simply being here and asking these questions, is not a passive byproduct. It is an active, essential ingredient in the universe's own recipe for consistency, binding the beginning to the end through the witness of conscious life. This final boundary is the silent architect of our entire reality. Think of the universe as a magnificent, self-contained sculpture. The artist begins with a raw block of marble, but the final form they envision, the specific statue they intend to create, dictates every single cut of the chisel from the very first strike. The heat death of the universe, or any other ultimate destiny, is that final, envisioned form. It is the master blueprint that reaches back to govern the initial conditions of the Big Bang, the strength of the fundamental forces, and the very flow of time. This ultimate cosmic shadow is not a place you could ever visit. It is a condition, a specific mathematical state that the cosmos is guaranteed to achieve. From our perspective inside the timeline, it is forever out of reach, a final chapter we are writing toward but cannot read, yet its influence is absolute. Why is the cosmological constant so precisely tuned? Because a universe destined for a long, stable evolution leading to this specific final state could not have tolerated any other value. Why does time have a clear arrow pointing from order to disorder? Because the final state of maximum entropy actively selected for a past of exquisite, improbable order, the only kind of beginning that could possibly lead to such an end. Every event horizon, from the one surrounding a black hole to the grand cosmic horizon defining the edge of our observable universe, is a local echo of this ultimate, final boundary. They are smaller shadows cast by the one great shadow at the end of time. They remind us that information is preserved, that the cosmos is a closed, self-consistent system, and that our reality is a story being told from its conclusion. Grasping the nature of this final state is the single most important goal of cosmology. It is the key that unlocks why anything exists at all, and why the universe is written in this particular code and no other. The search for this understanding forces us to confront the deepest mystery, that the ultimate answer to the cosmos may not lie in its explosive beginning, but in its silent, final breath. These disparate clues now converge into a single, startling image of reality. The holographic principle shows us a universe encoded on a distant boundary. Quantum retrocausality reveals a present moment shaped by future choices, the fine-tuned perfection of the Big Bang and the paradoxical preservation of information in black holes all point in one direction. They are not separate mysteries but different facets of a single, profound truth. Our cosmos is not a chain of causes stretching from a lone starting point. It is a complete, self-consistent system, a single timeless truth where the beginning and the end exist in a state of mutual agreement. The history we trace backward was never solely determined by its explosive origin. It was co-authored, its every chapter shaped by the inevitable final page. This is a new paradigm for understanding everything, a cosmology where time is not a simple, flowing river. It is a vast, interconnected web, a globally constrained structure where every event is bound to every other across the entirety of the timeline. Your local experience of cause and effect, where a dropped glass shatters on the floor, remains perfectly valid. It is the reality you live and navigate, but this new view places that local truth inside a breathtakingly larger context. The glass shatters because you dropped it, yes, but the entire sequence, from your momentary clumsiness to the scattered fragments, is also a necessary part of a story that is consistent from its first word to its last. This framework does not break the rules of physics as we know them. It reveals the deeper logic that makes those rules possible in the first place. It has the power to dissolve long-standing paradoxes, from the fate of information in black holes to the very arrow of time, by showing they are not problems to be solved, but illusions created by our limited, one-way perspective. This is a Copernican revolution for time itself. Just as Copernicus showed that the Earth is not the center of the universe, this new paradigm dethrones the past as the sole, unquestioned ruler of reality. The future is not a blank slate. It is a co-regent, an active force in a cosmic governance that has already been in place. Our journey through the cosmic shadow has brought us face to face with a reality reshaped. We have ventured from the event horizons of black holes to the farthest edge of observable space, only to find that the ultimate architect of our universe might be its own final state. This is not a universe that simply unfolds from a starting gun. It is a cosmos authored from its finale, a grand narrative whose every twist and turn is guided by the silent pull of its last page. The idea that the future actively codes the past remains one of the most profound and humbling concepts to emerge from modern physics. It suggests a cosmos far more mysterious and deeply woven than the clockwork mechanism we once believed in. Here, the beginning and the end exist in a constant, timeless dialogue, and every moment in between is a necessary thread in a single, self-consistent tapestry. While the evidence is still being gathered and the mathematical framework is being built, this perspective challenges us to think bigger. It dares us to question the most fundamental flow of our own experience, the arrow of time. The cosmic shadow we can never escape may, in the end, be the shadow of our own future, a vast and silent boundary reaching back through the eons to shape everything that is, everything that was, and everything that will ever be. This is not the end of the inquiry, but a new beginning. What do you think lies in that final chapter? Share your thoughts in the comments and subscribe for more journeys to the very edge of understanding.